All right, so good afternoon, good evening, everyone. My name is Marc Nikles. I'm the Chief Marketing Officer at ID Quantique, and I'm going to try to answer some of the questions that Carl brought up a few minutes ago, and tell you what we do at ID Quantique to help companies and government to become quantum safe. But maybe to start with, maybe a few words about ID Quantique. The company was founded in 2001 by 4 physicists of the University of Geneva. They had great ambitions to use quantum technologies for telecommunications, and they had this idea of improving the security of telecommunication. Well, at the time, the quantum computer threat was already identified, but still seemed to be decades away. But to their eyes, it was so significant that fighting that threat would be IDQ's mission from day one. Now fast forward to 2018, the quantum computer threat has become much more visible. Large telco companies started to be very interested in our solutions, and SK Telecom from the South Korean peninsula invested in IDQ in 2018, followed by Deutsche Telekom. And these investments have the opportunity to accelerate productization, industrialization of the product range, as well as have allowed large-scale deployments. Today, our headquarters is in Geneva, Switzerland. We have subsidiaries in Seoul, South Korea, and Boston, Massachusetts. We're set up to do R&D, engineering, manufacturers, installation, and commissioning support globally. 125 people in total, with large proportion of engineers and physicists. Let's look at the way we're organized. We're organized in 2 business divisions. On the right-hand side, you have the Q sensing product offering, which combines single photon detections and high resolution timing electronics to perform single photon detection and photon counting functionalities. In fact, single photon detection is a key functionality for the quantum safe product systems and solutions. And therefore, it was critical to fully master this from day one and to have full control over the supply chain. That's the reason why we have significantly invested in this product range since the start of the company. On the left-hand side, you have quantum safe security product range, which combines QKD, or quantum key distribution, and quantum random number generation, QRNG. On the bottom left, you have our QKD product offering, and then in the center you have, which is a product which is probably the first mass production quantum-based product that was brought to the market. It's QRNG, quantum random number generator chips. They are now integrated in several types of products, including a mobile phone, and on the picture you have the Galaxy quantum phone from Samsung. And today they're developing the 4th generation of that phone that includes this quantum key, quantum random number generators. Now let's spend a little bit more time on the QKD product offering. As Carl said, it's absolutely key to develop a product that is completely and fully compatible with existing telecommunication infrastructure. So that was at the core of our design efforts. And the 4th generation that we are presenting here includes 2 models, one designed for core, the backbone of the network, and a more cost-effective versions for edge of the network. These systems come with dedicated software for quantum key distribution and management to guarantee end-to-end post-quantum data communication security. Now let's illustrate how this is deployed in the field. Let's have a look at an example here. So this is what we have in Korea. This is called the G project. This is a network which is more than 800-kilometer long fiber optic network that makes the connection between different government agencies. On the left-hand side, you have the physical layer, which corresponds to the actual fiber link between the different QKD devices. There are 27 of them connected in series, forming one backbone ring and 2 peripheral rings. in the center, you have what we call the KMS layer, or the key management software layer, which is a virtual layer, which has been specifically developed to be compatible with multi-operators. We actually have 2 telco operators using that software layer to exchange keys. Currently there are 17 QKD nodes that are connected to this KMS layer, which means that there's 10 more that can be added to the software layer, and not talking about the additional QKD boxes that can be connected to these rings to extend the network. And finally, you have the red dots on the right-hand side that shows the 8 consumers, which basically are encryption systems used by government agencies that are exchanging keys. And the software is able to use optimized routing between the different QKD boxes, which in total makes a total of 127 secured links to manage, if you take into account all the options to route keys through the network. This is already deployed, active in Korea, thanks to SK Telecom and SK Broadband, the partner in this project. Now, why is this important? It is important, as Carl highlighted, because it cannot be excluded that encrypted data are being stolen already today. They will be decrypted with a quantum computer in the future. That's what we call the harvest now and decrypt later strategy. And because a lot of data have confidentiality duration requirements of years, and some even infinitely confidentiality requirements, so protecting data communication is very important today already. So what we're doing on a daily basis is to help enterprise company and telcos to become quantum safe by offering platform as a service or quantum safe as a service. So with this, I'm just going to ask you to stay tuned and join us in this exciting journey.